pleasure to be here, and unfortunately I'm only here for a week. I was intending to stay for another week, but industry meetings back in Australia next week don't allow that. But what I've seen of this country, I think I'd like to come back. In fact, I think I will be back very, very shortly. I've had the pleasure of working with PRF for probably 12 to 15 years when they've been travelling to Australia and visiting my research station, and it's an honour to be asked to come over here and hopefully give you a little bit of information and some guidance towards growing better canola. I think that my mother must have wrote that CV and not my mother-in-law. To lead in and talking about high-yielding canola, and I hope everybody can hear me up the back. Breeding canola for high yield. Look, this is a slide that Trent Potter, who has been to Australia, been to South Africa a couple of times, back in 2010 put this up, and we were aiming to get hybrids, canola producing 2 tonnes. So, and we still haven't, with an average, we're still under 2 tonne as an average, but we certainly have got canola to be able to produce a lot more than that. 5 tonne. That was the question I was asked to talk on, was 5 tonne canola. Is it realistic or optimistic? This was a crop at Lake Bolick in southern Victoria last year. It was a strip trial, one of our largest strip trials. The grower grew 5 tonne off this. And we've also got trials in northern Victoria under irrigation where we're getting yields consistently in the high 4s. And I'm not sure if Pete is here today, but he's been getting results very close to 5 tonne with some trials in South Africa. Really it comes down to not so much growing 5 tonne, but trying to get the maximum yield potential that you have. So the genetics, we've got the genetics now that we can produce high yields. The environment doesn't always allow us to do it, and we need to add another component, which is management, or the M, and that's really what you can control. So the idea is to hopefully be able to combine G by E by M, and I like to put that into another term, and that's MPY, and that's maximising yield potential. And that's really what I'm going to try and cover for you today. Not saying that you can grow a 5 tonne crop, but if you can grow a 3 tonne crop, let's make sure we do it. This is a crop in northern Victoria this year. It's one of our Roundup varieties. The grower made a comment that he wants to know what this will go. He's going to give it everything, and his aim is to at least produce 5 tonne. And we heard John talk a little bit about hybrids, and really that's where we're getting our yield potentials from. The first hybrid was released in Australia in 1988 by Pacific Seeds, and it took a long time for the hybrids to really gain traction and get going. In 2005, I released our first Clearfield hybrid in Australia, and farmers actually were the people that started to drive hybrids. They could see the advantages of hybrids in Australia, and it was something that helped pull through the process, was the farmers doing it themselves. In 2008, I also released the first Roundup Ready variety, and I hope like hell we can get Roundup or get GM material into South Africa very shortly. The hybrid system's available. There's 3 main ones. The Polymer system, which I don't think anybody uses, nobody in Australia is using it. The Agura system, which has come from INRA in France, and that's used by most of the companies in Australia. And the other one is a GM process, which is the Bayer Invigor system, which is a GM technology. The advantages of hybrids, John alluded to most of them, and I'll just go through most of them again. But seedling vigour, and it really comes back to the hybrids, larger seed in general, and they're able to give great seedling vigour. Increased biomass, and John talked about that as well, and I'm going to be able to show you some data on increased biomass and what that does for yield potential. Indeterminate flowering, if conditions enable with rainfall as we go through flowering period, the plant has the ability to continue to flower and therefore add yield to the plant. And it's important that if we can have the optimum plant population, it's better to get one main stem producing most of the seed rather than having a plant that's got lots of tillers on it, because the outside ones are the ones you start to lose very quickly when we come to bad finishes, and we see plenty of those in Australia. Uniformity at maturity, and that's one of the big pluses that farmers in Australia see. Growing hybrids, they are able to go in and windrow or even direct head with a lot more confidence of maturity being more even. High yield and oil potential, and that's one of the big things. Farmers get paid for yield, they don't get paid for looks, they don't get paid for disease. Disease helps in getting yield, but you get paid for what goes into the bin. Blackleg resistance, and going forward there will be a lot of other resistances we put into the plant. Standability, I'm going to put up some challenges with hybrids, and you're going to see standability in both places. But standability certainly in the early days with the hybrids was a bit of a worry, because we were getting a large increase in biomass, and we're also getting higher yields that we had to change the architecture of the plant to be able to handle the potential of high yield. So standability became an advantage rather than a disadvantage. And risk management. Some of the things that John talked about, and we're seeing it, we had a lot of opposition from people that were against hybrids, saying that with the biomass they'd grow too quickly, and in the more marginal areas they wouldn't yield, they wouldn't be able to finish. We're seeing the opposite. Not in every case, but generally across the board, we're seeing a totally different focus. In fact, in parts of the more marginal areas, not the real marginal areas, but in the much of the cropping area, growers are actually growing hybrids over OPs because of the advantages that they're seeing. The challenges, seed size, and John talked about seed size, and generally hybrids are larger in seed size, but not always. So sometimes it can be a bit of a challenge both ways. Height, if we're getting yield potential, generally we get height, so we need to be able to understand and manage height. Standability, as I said, it's not as big a problem now as what it used to be. And seasonal conditions, and that's the E, right, environment that we really can't control. So the challenges, I think the advantages certainly outweigh the challenges. Current traits in Australia, we have Clearfield, which is also in South Africa, Roundup Ready and Triazine Tolerant, also in South Africa. In the specialties, we have both high oleic and low linolenic, and there is a combination of both, but they are usually done through a closed loop system with Cargill, and a couple of other companies are doing some now, but that is quite a small but specialised market. Next generation traits. Sclerotinia. Everybody's going to hear about Sclerotinia, and I'm going to be talking about some of the work that we've done for getting increasing yield results with Sclerotinia, and we're also going to hear from Rick later on about using fungicides to control Sclerotinia. But there's been Sclerotinia varieties released in Canada. Pioneer's released 4 varieties over the last few years, and where anybody that's been to Canada will know that growers have been spraying up to 3 times for Sclerotinia. The latest variety that Pioneer released is taking it back to 1 spray, and in some cases not being sprayed at all. Better water use efficiency, John talked about that. There's a lot of work going on in Canada and also in Australia with that. Shatter resistance, Bayer, I think every company's working on it, but Bayer have released a couple of shatter tolerant or resistant varieties in Australia, and Pioneer, we're hoping to be able to release one in the next short time, so 1 to 2 years' time. The dwarf gene, there's been a lot of discussion about dwarf gene. It's currently in Europe and particularly in France. That's in the winter Napus material. It doesn't seem to show a lot of benefit to the spring programs that we use in Australia and here in South Africa. In fact, there's very little use of the dwarf gene in North America and Canada. So yeah, it probably doesn't show the advantages it does show with the winter material. Nitrogen use efficiency is, again, there's a lot of work going on. Pioneer's doing a lot of work in North America, and we've started doing some work in Australia. Clubroot, I hope you don't get clubroot. We have a couple of little patches in Australia, but it's not an issue, but it certainly is a problem, and there's varieties released in Canada for clubroot resistance. Drought tolerance, and the word drought is something that it's not something that I like to use too often, because you talk to our counterparts in corn in North America, they talk about drought when corn's gone 3 weeks without rain. We have to contend with drought. We don't get rain for 10 years. So it depends on which way you look at what drought is. But there is a bit of work being done. And the other one, that ties in very closely with drought, is heat tolerance, and there's a lot of work being done in Australia, particularly in Western Australia. We're doing some work in Wagga on heat tolerance, and that is basically at the flowering time to try and overcome those heat stresses. And the last one, which is going to come fairly rapidly, I would expect, as there's new traits released, and that is multiple traits. So whether it's a herbicide and a fungicide trait, or there's 2 herbicide traits being put together. The breeding direction going forward, and this is one of the reasons why I got out of research, was that I'm not smart enough to be a molecular breeder. There's a lot of hard work, and I just get amazed by when they put up a graph that we have a graph that's got a few bars and might have a couple of lines on it. They put up a squiggly thing and all these things around, and they say you can definitely see the difference between this one, and most of us go to sleep. So genomic selection, one of the great things with genomic selection is that it allows us for a terrific amount of throughput with material, which enables breeding value. So we're able to understand what we're putting into our crosses and whether we're making gains or going backwards. So it's one of the issues that one of the technologies that is really speeding up plant breeding across all crops. But we always need to do phenotypic trials, so that's why we still need the basic plant breeder, and that's no disrespect to the to a plant breeder. And that's understanding what the material is. So you're doing multiple locations to try and understand how they perform G by E. And the idea is to expose it as much variation as possible. We're just going to have a very quick plant breeding lesson, and this is quite simple, and it's hopefully just to explain a little bit of the issues that we have as we bring a new trait in. Adding traits is not new, but we need to be able to understand how it works. And this is a very simplistic way, and I hope that I don't embarrass myself or embarrass other people that are far more knowledgeable than me. But quantitative trait loci is QTLs. And most traits are coming in are native traits, so they really have nothing, they don't bring anything else of importance to us other than what we're chasing. And unfortunately, when we bring a new trait, and let's talk about Sclerotinia for instance, we know that it's got multiple QTLs. How many, I'm not sure, but it's multiples. It's more than 5 and probably less than 10. And on the chromosome, there's 19 chromosomes in the canola spring napers plant. So if you've got multiples and you've got 19 chromosomes, you've got a lot of action going on there. So the chromosome on the left-hand side is where you yield those yellow bars, the little triangles there, yield, and you've got a trait, and we're bringing in this trait, and let's call it Sclerotinia. And by using molecular markers, we're able to identify where that is. So we've got markers on the outside, but as you can see, I've got something called linkage drag there, and that's the yield penalty. If I go to the next slide, and we just lay out a DNA strand, and you've got, where are we? That's the trait, they're your markers. And just imagine, and that doesn't look like it's anything at the moment, but there's I was told many years ago that to explain that and what it really means to us, and this is what is all about yield penalty. If you had a street that and we'll call it Stanley Street, there's 1,000 houses in it, and the trait is in house number 520. That'd be fantastic if we just go to 520 and buy that, and we've got the trait. Unfortunately, the markers may be that you've got to buy 30 houses either side. So instead of buying one house for $10, you've got to buy 61 houses at a much greater figure. So that's just a simple way of putting it. What we need to do is, because of the yield, the linkage drag, which is this area between the markers, so once you make a cross, you cross them, so you've got on the chromosome on the left and the one on the right. When you cross them, you've got 50% of what you had on the left-hand side. So what we need to do is to be able to get recurrent selection back to the parent, and so when you cross them, you've got 50% of what you had before. You've picked up the trait, but you've lost 50% what you had. So you need to do back crosses, and to do BC1 back to the original parent gets you 75% of your original stuff back. So you do 6 back crosses or 7 back crosses, and that gets us up to around 99 point something. You can go through to, I think, back cross 12 or 13 to get you that close to 100, but it takes a lot of time to do that. So we usually stop on back cross 6, and we've got the trait in. But the idea is, oops, sorry people. The idea is if we've still got this yield drag in the middle. So when you bring in a trait, if we can get these moved together, closer into the trait, the better it's going to be. And we end up, that's the ideal. If we could get a plant with a trait, there's no yield drag on it, but we know, and Sclerotinia is one trait that we know that there is a slight yield penalty with it. So I hope people understand that. Or did you understand that, John? Just to bring us all back to earth before I go on to the next part, and that's the trial work that we've been doing on time of sowing. Australian agriculture, the good, the bad and the ugly, and we certainly have more uglies than good. This is what we'd like to see all the time. John showed the slide before that looked a lot like that. We're going through a fair bit of this at the moment in southern New South Wales, and we've been through plenty of that, being dust storms, or it could be a fire. What I want to go on to now is breeding. Still on the theme of breeding for yield, we're trying to understand, we need to understand as we go forward with hybrids, what time of sowing can do or can't do with hybrids. And there hasn't been much work done to date, and there will be a lot of work going forward, because it's very important to be able to understand, we believe it's very important to understand when we want to make crosses, when we want to make new hybrids, that we know exactly what's happening. So we started last year, was the first time we got going with this trial, and as I said, we're going to continue on for a long time. And that's sowing time, TOS sowing time, and we're looking at the effects of early vigour on NDVI, which is, I keep forgetting what that is. John? New Normalised Difference Vegetation Index. Yeah, that's very important to remember that. Effect on phenology by hybrid, effect on flowering duration, effect on then that comes into the effect on sclerotinia infection, and effect of yield and oil. And the last two slides that I want to talk about and put up, and I hope that you'll be able to read them well enough, is yield consistency by year. Not necessarily always chasing number one, but getting yield consistency. The objective of this time of sowing trial, and everybody can read that, but to establish hybrid performance sown at different times, better understanding correlation between early biomass and yield, to better understand hybrid phenology and effect on time of sowing on flowering, to determine what drives flowering time by hybrid, so looking at the growing degree days, photoperiod units being the sunlight, vernalisation, not that we have vernalisation issues or we need vernalisation in Australia, and I'm not sure that you will have an issue here, and a combination to see if there was a combination with all of those. And the last was to determine if flower sowing time affects disease development, which we're going to be talking about is sclerotinia. Now this is a very quick snapshot of a very intense and a lot of data that we're able to generate. We have two sites in southern New South Wales, very close to Wagga, and we're just looking at trying to, and we're using the NDVI green seeker machine and going forward to understand when it's the best time to be, and I think John suggested that early biomass, and we know that, as I'll tell you a little later, but the three sowing dates were the 9th, the 23rd of April and the 6th of May, 1 day apart at both those sites. And the ideal time to do NDVI is around the 2 to 3 leaf stage. Unfortunately, we only had the access to the machine for 1 day, so we had to go and do it all on the 1 day. So if you look at the three graphs or three bars at the bottom, that's sowing day 1, 2, 3. All this tells us with 1 and 2 basically is that there was a lot more biomass, so there's no story there at all, there's no correlation, and that's what you'd expect because it was taken 88 days after sowing, when really the optimum time should have been back at around 60 days at 2 to 3 leaf stage. The same with sowing time 2, but a really great correlation here on sowing time 3. We're in the process this year of making sure that we're taking the NDVI at the right time on sowing 1 and sowing 2. So yeah, it really, the correlation is really great, biomass relating into yield. The summary of the NDVI, and John made reference to it before, what happens early really matters. Canola sets its yield potential early, and the question before about having stubble on and having moisture, that's really driven a lot of the farmers sowing earlier in Australia because they believe they get the crop up, can get it up and going, and that early biomass certainly is helping. Accumulation of leaf size and biomass between emergence and 3 leaf stage is highly correlated with end yield. Time of sowing 1 and 2 had more rapid canopy closure. Sown earlier, warmer temperature, hence a lot more rapid canopy closure. Early sowing resulted in greater weed competition due to increased biomass, which is quite understandable, and the same with early shading, so it comes back that we've got good stopping the evaporation rate by the earlier sowings. And there is likely to be a level of early biomass in most cropping situations. Doesn't have to be canola, but in most cropping situations, depending on soil type, temperature and rainfall distribution. And John was alluding to the same. This is some work looking time of the effect on days to flower. And down the left-hand side, we've got a list of varieties, and the blanks here are for experimentals, so it's pointless putting up there. But we were able to identify 3 distinct groups. So if everybody can see the one on the left-hand side, the red circles. We've got a purple circle here and a purple circle there, and then the 3 or 4 blue circles. The circles on the left-hand, mainly on the left-hand side, the red circles is the cumulative heat units. So if you look at, I'm not sure if everybody can see the colours over on date 1 or day of sowing 1 is the yellow, time of sowing 2 is the green, and time of sowing 3 is the blue. They generally fall in order of their, thank you very much. They generally fall in order of when they were sown. So first time, second time, third time. And what that means is that as the heat units, it starts to flower when the heat units get to a certain stage. So it's cumulatively the heat units. The second, we'll talk about the blue ones here, which is, if you look at it, is generally the opposite. So we've got the last time of sowing is coming in earlier than the longer season. And what that is telling us, that's the day length trigger. So once it gets to a day length, it's flowers. So that would be the opposite, because the day length suits the earlier sown, the later sown more than the earlier sown. And then the last group is here, which is the fixed, fixed sowing time. So it doesn't really matter what the weather's doing. When you sowed it, it gets to a day and it starts flowering. So we've been able to identify basically these 3 groups, and it's going to give us a lot of information as we go forward with some of the new experimentals, and we're using it as a breeding tool now to understand when we put a hybrid out, we should be able to give you information. If you sow it on this day, what will happen with that variety? And I think that going forward is certainly going to give you the opportunity to maximise yield potential, and that's really what it's all about. To continue on with that is looking at the and this is with Clearfield's varieties, the flowering duration, looking at how long they flower for, and then we're able to overlay, and this shaded area here is the sclerotinia infection period. So I'll move on to the next. That was the infection window. So time of sowing 1, 2 and 3. 1, 2 and 3. And this was the length of flowering is the blue bars. And this was the infection period. And this information we were able to collect. We had a PhD student collecting the information, and this was at this information was taken on the amount of petal infection, and we were able to identify that wherever we were doing the testing, that we had 100% petal infection. Didn't always say that we got disease, but this is the infection window, and as you can see with the early sown material, it didn't really matter what maturity it was, they were being affected. So the lower the score, this here is the sclerotinia infection, 1 to 9 scale, 1 being bad, 9 being good. So this is, as you can imagine, anything that's got into the window of infection, the lower the score. As we come into time of sowing 2, it started to get better. Time of sowing 3, we really had no issues. If we had this is not just a straight bar, this should have a bell curve, which in most situations you're going to have some variations. Hence you'll see a little bit of difference here, which it says that it falls outside, but it really does get affected. And on the right-hand side is the yield. So that is giving us a lot of information. We're going to hear from Rick later on that's going to talk about when we should be spraying Passaro for sclerotinia control. So this information is something that we believe is really going to be helpful as we go forward, as we bring out new hybrids, to understand the flowering time and when the risk for sclerotinia is going to be. So the summary, very similar to the one before. First time of sowing had greater NDVI biomass on the 6th of July. Obviously it was had a lot more growth there. Hybrid days to flower was affected by time of sowing. Flowering duration was shortened with later sowing across all hybrids herbicide technologies, which is what we had hoped that would happen. Sclerotinia infection was highest on the earlier sowing, so it was out there for a longer period, and that makes sense. An early time of sowing resulted in higher yields. 1 and 2 out-yielded time of sowing 3. And I haven't mentioned anything about oil, because in this study there was no real difference between the oil on the time of sowing. So now I hope, now this is probably not easy to read, but this is coming back to consistency, why it's important to not always chase the highest yielding, but to have something that's going to be consistent across a wide range of environments. This is NVT, or the National Variety Trialling System in Australia, across years. So 2012, which was a very wet finish. 2003 was a pretty ordinary year. 2004 wasn't too bad. And in some areas, 2015 was very good. But the thing, it's not to say one variety is better than another. It's more to show how some varieties do perform. This is Clearfields again. And I think there's roughly about 30 sites in each year. So we've got a combined 120 data points plus replications. So there's a lot of information here. But the idea, and just to explain what the red and the green and the yellow bars mean, they were above the mean, the yellow is roughly the mean, and the red is below. Now, a red bar doesn't always mean that it was the lowest yielding. It also, because companies tend to try and cover a few bases, they put varieties in, not always in the right maturity group. They're trying to cover lots of bases. So some of these red bars, and this one over here is a classic. I don't know why they would have put this as a late variety, and they've put it in a lot of early sites. So it was certainly going to be affected. But chasing yield is, people say, oh, we want to get 5 tonne or we want to get 3 tonne. Always want to pick the highest yielding variety. Well, I can assure you that this variety here, Y86 in Australia, is probably one of the highest yielding Clearfield varieties. Y88, where's Y88? Back here, Y88 is probably the most consistent high yielding variety. And then look at Y87, had a fantastic year in 2012, and it's come back, didn't do so well. We took it out because of short seed supply, but it's performed fairly well, except for a couple of spots in high rainfall area, which is probably out of its active zone. But 89, which is one that we released in South Africa, it's going to be available for next year, has got a lot of green bars, so it's really, really consistent. Not always the highest yield, but very, very consistent. Just to give you a bit of a snapshot on Roundup Ready, and there's much discussion on whether Roundup Ready's better yielding or less yielding than others. All my work has shown to date that Roundup is marginally behind Clearfield, and I can give you a quick answer to why that probably is. We were taken out of the market, the trialling space, breeding space, for 6 years when there was moratoriums put on. So, but as you can see, with the Roundups, Y23 is an early hybrid of ours, high yielding, but it also has the ability to be very high in one site and down in another site. So environment really plays a big part. But something like Y24 is very, very consistent across most locations over a long period of time. Look at something like this one here, which is it's very early. As you can see, it's probably been put into a lot of places where it's not so good. It is a lower yielding variety, but some of those red bars are probably being exasperated by being in the wrong spot. So that's something that we look at to see. As I said, if you're trying to chase number one all the time, you'll be changing every year, and that's not always easy, and it's certainly not good for seed companies because we think we're on something that's going to work, and then somebody wants to keep changing all the time. So that work is, we're going to continue to monitor and work with this because we see that there's great advantages of understanding whether a variety or a hybrid is a good one. So, and really what we're trying to do is take the highs and lows out of yield and level them off so that they just have little waves. We're not surfers, we don't need to be chasing the big waves. But it also is a point as far as the Australian canola industry is concerned, because we export over 70% of our canola. One year we're producing 3 million tonne, the next year we may only produce 2 million tonne. So we're trying to get consistency across the board, not only with hybrids but also in performance. So with that, I'd like to acknowledge PRF and the group that have all been to Australia, and thank you for bringing me here and looking after me. It's been a great pleasure to be in your country, and what I've seen, particularly of the southern part, it is gorgeous. To Pioneer Hybrid, or DuPontPioneer in South Africa, to Jim and Tony, thank you very much for your support. The support from the new breeder we have who replaced me, Dr. Ray Cowley, and Clint Rogers for some of the work that they did with this presentation. Kurt Limbrick from New South Wales Department of Ag, who is the pathologist and the expert on sclerotinia, and also the GRDC, which own the NDVI data. So thank you very much, and I really hope that I was able to enlighten everybody on high yields.
Rob, from what I understand from you and John is that you are promoting early sowing systems in Australia. Does that mean that the new cultivars will also be best suited for early sowing systems? Because if that's true, we in South Africa, using your cultivars, will also have to adapt that approach.
Very good question. One of the biggest issues that we have, or one of the biggest challenges we have with early sowing is getting the farmers to go back only 3 or 4 days or 5 days when they decide they want to try an early sowing. Unfortunately, this year in parts of Western Australia, and Rick will be able to back me up on this, these farmers have gone back. Instead of being our traditional window for planting used to be Anzac Day. Anybody that doesn't understand, Anzac Day is the 25th of April through to the 10th of May. We've now kept early sowing is probably around the 15th of April through to the end of April. So we're just moving back. But unfortunately, farmers have actually gone back to early and even late March, but some of them have planted early maturing hybrids back then. So it's going to be a bit of a wait and see what happens this year, because we had, and Rick told me yesterday, that there's a few growers that have got Y23, which is an early Roundup hybrid that was flowering at the end of May. It's a long time to harvest in October. So to answer the question is yes, we are shifting everything, but we also are making sure that we have different maturities to be able to handle that. And our suggestion to farmers is, if you are going back, don't go too early, but if you're going back in, put your longer maturity variety in first, and then put your earlier one in second. Most people grow more than one hybrid just to spread risk, but it was pointless putting in a mid-maturing one in on day one, waiting 15 days, putting the next one in, they both flower at the same time. So my recommendation, my suggestion is that find out when the ideal time to plant and don't go too far earlier than that, and pick your right variety to put in there. So don't always just rely on one variety to cover all bases.
So one of the issues with earlier sowing is that the canola plant is flowering in response to day length. So if you move it back in April, the day length is changing very quickly. It's getting shorter days, and it's on that bit of the curve where the days are getting shorter at a very rapid rate. So moving back 4 or 5 days doesn't sound much, but in day length change at that point, with our varieties, which are very sensitive to day length in their flowering response, it makes a big difference. So I think coming back to Rob's talk about the QTLs and the new genes, we're only just starting to learn about the genetic control of flowering time in canola, which genes are controlling the response to both day length, to vernalisation, to cold, and also to heat units. So once we have a bit more of an understanding about those genes, it'd be much easier for the breeders to say to you, this variety's got these set of genes, it's going to flower in this way when it's sown at this time. But you're right, Andre, the mistake to make is to think that with our current varieties we can just sow them earlier and have the same result. You have to know that the variety suits an earlier sowing, and we had to learn that by a bit of trial and error over the last couple of years. Varieties we would have said are mid varieties, you even take them 3 or 4 days earlier, they start behaving very differently. Other varieties you can move back 2 weeks and they're very stable. So we need those stable varieties that give the farmers a bit of flexibility on their sowing time, because it's the flowering time that you're really trying to manage.